When we were talking before about the number of things inside of a set, or the number of elements inside of a set, we'd say, oh, well, this set has 3 elements, or this set has 4 elements. That actually has a special name, and it's called the cardinal number of the set. And the way we denote it is with this little notation right here, a little n, and then in parentheses we do an s, meaning the number of elements inside of set S. That's called cardinal number. So your set can have 2 elements or 3 elements or 5 elements or 500 elements, just depends on how big your set is. There is one special set, and that is the set that's called the empty set. It's also called the null set, that's its fancy name, and that's a set that is legitimately just empty. There is just nothing inside the set. So you can denote that by drawing literal empty curly brackets where there's literally nothing inside the set. That's an empty set. Or you can write a 0 with a slash through it. Either one of those will both denote empty set. Just don't combine them together. Sometimes students try to do this, and I'm like, oh, you just put something inside the set. So that's not how we say it. That's not how you want to do it. Just one or the other. I kind of like this one that's just literal empty curly brackets. So that would have a cardinal number of 0 because there are no elements in the set. So its cardinal number is 0. For every other set, though, you should be able to count and see what the cardinal number is, and it's literally just counting. So for set A, it's asking what are the number of elements in set A. You literally just count, there's 5. The cardinal number for set B, there's 1, 2, 3, 4, 5, 6, 7 elements. For set C, there's 1, 2, 3, 4, 5. There's 5 elements. So it's literally just counting. You don't have to do anything special. You should always get a whole number. Whole number meaning 0, 1, 2, 3, 4, etc. So what we learned before is that 2 sets are equivalent if they have the same cardinal number. And that's the basis of this idea behind equivalent or not equivalent. So for example, sets A and C would be equivalent because see, they both have 5 elements. We could say A is equivalent to C if we wanted to. All right, there's 2 other types of sets. We have what are called finite sets, and we have infinite sets. And I think they probably are what you think they are. A finite set would have a cardinal number that's a whole number. It's got to be a whole number. So 0, 1, 2, 3, etc. Those are whole numbers. So examples of finite sets. The empty set, that's finite. A finite meaning a countable number of elements. It's 0 elements, right? 0 elements inside the empty set. This is a finite set. It's got 4 elements. That's a whole number. Fish, dog, cat, that's got 3 elements. That's a whole number. So see, as long as you get a whole number for your cardinal number, it's a finite set, meaning you can actually count the number of things. An infinite set would have, well, an infinite number of members, meaning these are going to be the sets that have the ... in them. So natural numbers, for example, that's 1, 2, 3, 4, etc. See the ... that goes on forever. That would be an infinite set. The even whole numbers, so the whole numbers that are even, 0, because 0 is technically an even number, 0, 2, 4, 6, 8, etc., etc. This goes on forever. That's a way to say infinite. Both of those sets are infinite. So that's the difference between a finite set and an infinite set.